Thank you so much for joining us today on Connect and Collaborate, where we come together each day to introduce you to our network of business and community leaders and to discuss issues that impact business. This week, our focus is on Denver's build-up. We're taking a close look at the developments and construction projects and those partnerships that contribute to our growing metro area. And today, we're connecting with David Brooke. He's a project manager for Hensel Phelps, building the new Gateway Center for Lockheed Martin. David, thanks so much for being here.
Yeah, thanks for having me.
This is so exciting. There's so many great projects coming up in and around Denver, and for these companies that contribute so much to our economy to begin with. So as a project manager for Hensel Phelps, tell us what you do.
My primary role is to support owners in development of their projects from inception through construction and closing out, and in the sustaining the operations of that building after it's completed. As owners are developing, they have schemes and ideas that they're looking for, and it's our job to help them get those onto paper as design and constructed.
Right, so it's more than just building the building, it's more than just the construction, and we'll talk about this more coming up. You really had to design something that's never been designed before.
Correct, yep.
At this scale, probably.
Yep.
So let's talk a little bit about Gateway Center. This is going at Waterton campus. It's a $350 million project.
Correct, yep.
2,000, wait, I'm bad with numbers. Let's reorient this, 266,000 square feet.
Yep.
That's huge.
Yep, it's a large building, and what's not captured in that is the volume.
Right.
Much of this space is over six stories tall, clear space. So the height of all of these spaces is really large.
So 6 stories, and probably it's all open space for 6 stories.
All open space within there. And that's the height that they need for the assembly of the spacecraft, the satellites that they're building within there.
Spacecraft and satellite. That's amazing.
Yep.
So tell us what that's going to. That makes Waterton campus. It's going to make it up to 35 million square feet of production, engineering, test, and office space.
Yeah, 3.5. So with the
3.5. I missed my decimal. I'm sorry.
Yep.
3.5 million.
Yeah, with the addition of the Gateway Center to Lockheed Martin Waterton campus, that's going to bring them up to 3.5 million square feet of production facility, all at that campus, which makes it one of the largest satellite and aerospace manufacturing campuses in the world. So it's a lot. They have a lot of space out there.
Can you speak to this? How important is that to Colorado to have this big of a facility for Lockheed Martin Space Systems for what they're building here?
Yeah, and I'll talk to a little bit. It's more on Lockheed's side,
sure.
But what I can say is, this project is a strong step in what's continuing in the aerospace growth and development in Colorado. It's not just with Lockheed, with other companies here in Colorado, we're seeing a lot of strong growth from the aerospace sector, which I think is extremely strong for construction within Colorado, because it gives us another sector that we can rely on for steady sources of construction jobs and construction work.
Well, that's just it. We'll talk more about the purpose of the building, but on the construction side, how many jobs are we talking about to build this large of a facility?
Yep. So for this project, there'll be over 1,000 construction jobs that are created out of this project. 1,000
jobs in construction, and how long will that go on for?
So the project's 30 months. I think we'll get into this a little bit later, but we broke ground in June, so we got about 26 more months of construction.
That's a lot of good work for some skilled laborers, isn't it?
Very, yep.
Broke ground in June. So let's go back and talk a little bit more the purpose of the building. So it's satellite manufacturing. What goes into creating a structure for this kind of work?
Yeah, so it all started, so we, as Hensel Phelps, we were the design builder. So our first step was to understand what was Lockheed's needs for the facility, and then to go put together the correct team so we could go design this facility. So I'll give a little shout out to them. Davis Partnership is the architect. Martin & Martin did the engineering. Maxon Engineering did the mechanical, and RMH Group did the electrical engineering. That's the team that we brought together based on their special skill set for this specific facility. But all started with understanding what was Lockheed's requirements. What were they going to do in that facility, and not just what did they plan to do, what might they do in the future, or what might they want to do in the future, so we could plan for today while still trying to plan for future.
Right, because who knows? Okay, so this is a space to build spacecraft or satellite.
Yep.
It's mostly satellite at this point?
Yeah, it is. It's the term is interchangeable. So.
Okay.
Yep.
But thank you for educating me. But who knows what satellites are going to look like 10, 15, 20, 30 years from now, and you're investing this much into such an incredible building and facility. You do have to think ahead to how this is going to work.
Exactly, and so they challenged us with lots of different. Hey, what if we want to do this 10 years down the road? How could we accommodate that? If we want to test this way, how can we accommodate those? And so we ran lots of different diagrams and lots of different layouts. I mean, this was a course of 2 years of I would say it's more trial, not necessarily error, but lots of trial for what could we do and what could we accommodate, all while trying to stay within the budgetary requirements of the project as well.
So I'm looking right now on the LockheedMartin.com website at Gateway Center, the artist rendering. I love artist rendering.
Yep.
And that's a good-looking building.
It is. It's their future, right?
Right.
And it wasn't not just intended to be just a square manufacturing box, right? It's supposed to bring back a sense of pride, but also with that too, that's just standard metal wall panels right there. So I got to give credit to the Davis Partnership architect team. They put a lot of effort into creating an appealing building, but still it's a manufacturing facility. That's what it is.
That's interesting because on one hand, it's kind of like an airplane hangar, a little bit on its side because you needed the height.
Yep.
Yeah. But also a manufacturing facility. So there's probably, I'll have you describe the interior as we get back from break because we only have a couple seconds left here. But I want you to describe for us when we come back just all of the, I guess, imagining that needs to go on to create what you need. It's something that's never been designed before.
Yeah, absolutely. Love to talk about that.
We are talking today with David Brooke. He's project manager for Hensel Phelps, and they're working on the Gateway Center for Lockheed Martin Space Systems. This is part of our focus on Denver's buildup, all of those great projects that are going on that help drive Denver's economy, Colorado's economy. We'll be right back. We're so glad you're staying with us today for Connect and Collaborate, and we're wrapping up our focus on Denver's buildup. We've been taking a look at the developments and construction projects and partnerships that are contributing to our growing metro area, and today we're connecting with David Brooke, project manager with Hensel Phelps, and the project you're working on is massive. This is the Gateway Center for Lockheed Martin, Waterton campus, right?
Correct.
So tell me a little bit about what the basic functions of Gateway Center. What's going to happen there that you had to design for?
Yep. So the primary functions is the assembly of satellites. So that they accomplish that in what's called a high bay. It's a clean space where they go and essentially build, assemble the satellite. A key function of this building that they wanted to have all centralized and housed under one building and under one roof was the test components of it. So after they assemble it, or in certain stages of the assembly, they take it in what they call these test chambers, which simulate space environments, highly complicated space simulation chambers essentially, and they test them. And so they want to be able to move it right from the assembly area over to the test area and then back to any final assembly areas that they might need to do before shipping it and launching it into space. So in a nutshell, that's the function of the facility.
And that is so they can build it as much in one place as possible.
Yeah, yep. So they don't have to package and ship it to different areas, either on the campus or different areas across the country, which obviously saves money and because
Well, yeah. Can you imagine moving this thing?
Yeah, exactly. They're very expensive, and shipping them is a process that is.
And I would think you're better off if you only move it when you're ready to launch it.
Yep. The less moving it, the better. So, except for when they're testing it.
That's amazing. And I'm looking at some pictures on the website at LockheedMartin.com. There's a clean bay room where you build and test these things. They explain that to me a little bit. What kind of you can't have your regular Colorado dust on these
Right.
components.
So yeah, within the clean room. So these are 100K class 100K clean rooms. What that means is it's just basically very clean air, high HEPA filtration systems, and they move a lot of air. These are moving upwards of 8 air changes an hour, and with the volume of space, the mechanical systems required to condition and move that much air is immense. So the mechanical systems to maintain the clean on this facility are equivalent to building 6 to 8 times the size of this facility. It's a major component of it.
That's incredible.
Yeah.
So we're talking with David Brooke. He's project manager for Hensel Phelps, working on the Gateway Center for Lockheed Martin Space Systems. And tell us about designing this. This is something that first of its kind?
Yeah, I would say, I mean, there's been, high bays have been designed before,
Sure.
The test chambers have been designed before. Some of these are on a scale larger than typically designed, though, and really pulling them under one roof with highly thought through plans for future expansions or renovations is, I think, the key piece that this facility really went through. So no real basis of design to start from with this thing. It truly started as someone's idea, napkin sketch that I'm not joking, it sounds cliche, but was sketched on a napkin, and that's what we got to start with, and that's what we did our first estimates based off of that. And from there, we started asking Lockheed questions and getting the information about how they were going to use that facility, how the satellites were going to move through there, how they might move through there, and that's where we started designing, and they started testing those designs.
Mm-hmm.
How
do they test a design?
That's what I was just going to get into. So we relied heavily on BIM for this. So 3D, everything was designed in 3D. So we would put the satellites in within the space in 3D, and we could animate it and move those processes through the facility. So
and so
Yep.
you need to know if it can turn around within the facility, or maybe open this.
Yep.
I'm going to use the wrong word. I'm just going to say some kind of wing or something that's going to open
can
up.
the solar deploy, right? And that's what powers it. Gets power from the sun. Can that deployment open and not hit the walls, right? Can they take it out and into the test chamber and make the maneuvers without hitting the walls? So doing that sounds simple, but when you're doing it for a satellite that hasn't been designed, that's where Lockheed was really challenged on getting the information to us, and then we take that information and put it into the building and see what the building would look like, and then what it cost, and how could we make it more efficient. So,
do you have nightmares that the building is built and they're trying to turn the satellite around inside?
Yes, yeah. When they successfully take one through, I'll be sleeping much better. So
I'm sorry, I just pictured that. It's like those work-related nightmares.
Yeah.
So it's like, what would that have to be? It's like, and then boom, it bangs against the wall.
We also had a great opportunity on this project, though, to go and leverage virtual reality and augmented reality, though, because we did all this design in 3D, and the technology has been making leaps and bounds from virtual and augmented reality. Is we'd actually put the virtual reality goggles on Lockheed people, and we'd be able to put them in the space with their satellite and let them feel. I mean, because they're the guys that are building the satellites, they know what space they need. They could physically see their spacecraft in there, and they're like, I have the right clearances I need, around it to go put the parts and pieces on it. So that was a good attribute where technology had caught up and we were able to leverage that. And
how do you then... That's for spacecraft now. Like you said, first it's something that hasn't been built yet, but they know what the design is, so they have better than a good idea. But you're also designing this for what the future's going to hold, because you're not just building this massive building for one go of satellites. So how do you design for something not only that hasn't been designed yet, hasn't been invented yet, what the future holds?
Right. And so that's where Lockheed would give us parameters. Like, so, should someday we want to do this, how would we accomplish that? And so we would go and design that option, and we'd test that option out, and we'd look at a way that we could do that as an expansion or as a renovation. So there's a lot within this facility. It's already pre-set up from the mechanical systems, and the structural steel is designed for future expansions and additions to accommodate any of that future growth, based off of whatever could be forecasted today in their imagination for what a satellite will look like in the future.
So also mentioning that obviously it's a manufacturing facility as well. So what goes into that design? As I'm looking at the artist rendering a little bit, I'm seeing different floors that are up in this what's an open space 6-story building.
Yep.
So and can you walk us through it a little bit?
A little bit, yeah. So the big component is the high bay, right? And that's where they assemble it. But it needs a lot of support space as well. So there's multiple levels of office that is within there, break space, because this will hold, at operating capacity about 100 people on a daily basis working within this facility. And that's just on a single shift. If they're running multiple shifts, they'd be having lots of people working there. But so there'd be a lot of people. So it's office space, break rooms, back of house support space, storage. There's a lot of storage space that's required to support the assembly operations.
Wow.
Yeah.
So we're talking again with David Brooke, project manager with Hensel Phelps, and they're working on Gateway Center for Lockheed Martin at the Waterton campus. And I just want to run through some of these numbers again. I'm going to get them right this time because I put the decimal point where it belongs. So it's a $350 million project at 266,000 square feet, bringing the Waterton campus up to 3.5 million square feet, and that makes it
one of the largest operations at one campus in the world.
The largest satellite and space manufacturing center in the world. What excites you most about this and having designed it and groundbreaking in June already?
Yep.
Right.
Already had the groundbreaking. It's extremely fulfilling and a little bit of a pinch yourself type moment of seeing it actually being constructed after working on it for so many years, conceptually and virtually, designing, redesigning, estimating it, and then seeing the actual construction going in place is wildly satisfying. In fact, when I go out on site, I pick up some dirt and just to feel it, is this really real? We're really doing this. So that's one aspect of it, and the other aspect that's is huge is the partnerships.
Right.
Is through this working with the design team, working with Lockheed Martin, now working with our subcontractors in actually building this. I think for me, it's working with the people and seeing like a plan that was truly a napkin sketch turned into a world-class facility is just unbelievably cool.
They need to frame that napkin
and
put it
exactly.
in the entryway.
I know.
Just saying. That's obvious.
Yeah.
But also with the jobs it's bringing for the construction, and not even talking yet about the jobs that will be brought to Lockheed.
Yep.
In this, but the construction jobs, and that's a challenge still.
Oh yeah. Yeah, I mean, I don't think there's any surprise about the skilled craft and the shortage that we have right now. There's a lot of great programs out there, like Construction Careers Now. I think you hosted them last week on here. It's a great program. We're big supporters of that. But we got 1,000 jobs to fill through the construction of this project. There's over 1.3 million man hours of work that needs to go into this project. One of the things, Construction Careers Now is doing a great job of bringing in more folks into the industry, but in support of our partners through this, something that we're trying to do is we're trying to buy out and subcontract the work earlier, allowing our key partners, our subcontractors, more time to plan for this work and to get this work into their backlog.
So meaning normally you could, 3 months before you need to start working on one aspect of it, you could normally call up your electrician teams and say, so you have guys to work on this?
Right, exactly.
And they would normally say yes.
Yep.
Now it's a little tighter.
Yeah, you need to plan further in advance.
Wow.
And I think that's healthy for the subcontractor market as well, because they can, instead of planning just 3 to 6 months or 1 year ahead, now they can start planning out 9 months to 2 years ahead and having work secured up, which gives them some good security for their companies.
Wonderful. Thank you so much, David Brooke, for coming in and talking with us about this fantastic project of Gateway Center working on for Lockheed Martin. Coming back, we're going to talk with Lauren Issac from Easy Mile. Stay with us. Thanks so much for staying with us today on Connect and Collaborate. Today we are talking about the build-up in Denver. So many developments, construction projects, partnerships, and different companies moving to Denver with great I don't know if we should call this a product or innovation. I'm talking now with Lauren Issac. She's the Director of Business Initiatives for North America for Easy Mile. Lauren, thanks so much for being here.
Thank you for having me.
So this is exciting. This is driverless technology, and it's a shuttle. So this isn't something that's necessarily going to go in at DIA. Or is it?
Why not?
Why not? Yeah, why not?
Yeah.
So describe this innovation a little bit. It's a driverless shuttle. It's not on any track. It doesn't require any infrastructure. It just can go drive 15 people around.
Yeah, so it's a driverless shuttle. We call it the Easy 10. It fits 12 people, 6 people seated, 6 people standing.
Okay.
It has an automatically deploying wheelchair ramp, so it's actually accessible for
that's
people
great.
with wheelchairs or strollers. We actually had a demo about a month ago at the Pepsi Center, so we had a lot of people from the Denver area getting to experience it for the first time. But it can operate completely autonomously. It does operate on pre-mapped routes.
Okay.
So that's what makes it what's called a level 4 autonomous vehicle. And the vehicle can operate at speeds up to 25 miles an hour. So we're not going to be on the highways at this point, but there are a lot of different cool use cases that it can help solve. It could be at an airport bringing people from...
Right, so you've got the shuttles that now go from the airport out to parking lots. So you could do that.
Yep.
For one example.
For one example, we have shuttles operating at business parks and transporting people around on a private employer site.
Oh, wow.
We have a couple in Arlington, Texas, where the shuttles are transporting people from a parking lot to a sports stadium. So it can fill that first and last mile gap.
Yes.
That especially in our transportation world, it's a huge challenge.
I could see that maybe then in some areas where, let's say the light rail goes so far, and maybe, apartment buildings that are nearby. So at least you've got the safety of being in a shuttle.
Absolutely.
Cool.
Yeah.
Well, and when we were talking last week as we were getting ready for this show, I was picturing I was at a resort in Hawaii, and they had such a big campus, huge resort, right? And so they have a train and a little boat that would take you to the different hotel buildings. So this would be something that could be put in that kind of situation, but without having to build a track.
Yeah. So when you think about the many, many applications combined with the cost savings, it's actually really amazing. And I think one of the most exciting things about the driverless technology is the safety benefits. When you eliminate the driver, you actually have the potential to eliminate over 93% of the accidents that are happening on our roadways today.
Okay, that doesn't sound like what it sounds contrary to what we would think, contrary to our perceptions. How is it safer?
Well, we humans like to have control over things,
This
so
is
I
true.
understand why it's hard to imagine pulling that away. But at the same time,
This vehicle needs me to steer it.
Exactly. But if you think about the accidents that happen on our roadway today, it's actually proven that 93% of the accidents that happen are due to speeding, distracted driving, drunk driving, all things that are caused by human error or human bad behavior.
Right.
So if you eliminate the humans from the equation, you have the potential to make our roads many, many times more safe.
So let's talk a little more about how Easy 10 and Easy Mile are coming here to Colorado. So you're located sharing space with Panasonic out on Peña Boulevard.
Yeah. So we, as a company, Easy Mile is headquartered in France, but we are really excited to be entering the North America market. And we had to make a decision of where we wanted to be in the country. And our CEO looked at quite a few different cities around the country and ultimately decided on Denver. And that was in large part because of the relationship that as a company we were able to establish, not just with Panasonic, but also with the city of Denver, at the state level, the Colorado Department of Transportation, and organizations like NREL. We were talking to all of them and found it to be a very positive ecosystem to become a part of.
Well, that is one of the things we can brag about for Denver is that it's such a great environment for any kind of entrepreneurship, developing businesses. There's such a collaborative effort here.
Yeah.
That it just makes it that much easier.
Absolutely. And knowing that we're going to be growing over the next few years, it's a great place to find a very talented workforce. So
Speaking of which,
yeah.
yeah. So what kind of jobs come with Easy Mile locating in Denver?
Yeah, so we just hired a new director of sales for North America. So we're excited about that. He's starting in a couple of weeks. And then we're looking for more people on the technical side. We have job openings now in both project management and as deployment engineers. So we're looking for folks with technical experience, and we understand these people are probably not necessarily coming with driverless vehicle experience.
Okay.
So
Right, because not so much of it.
exactly, it's still a pretty new area, but just people that can kind of have an aptitude to learn and kind of strong skill sets in the engineering area.
Oh, that's fantastic.
Yeah.
How many jobs do you have an idea?
For now, it's on the order of just a few people, which is at this point still doubling our workforce in North America. and over the next few years, we can see ourselves getting up to 20 or more people. So we think it'll grow pretty significantly. We have a big enough space to house more than 20 people. So we're excited about the growth.
Where are these vehicles? Shall I call it a
Yes.
vehicle?
Yeah. Yeah.
Where are they manufactured?
So, as a company, Easy Mile is actually a driverless technology company. So, our focus is on the actual software
Okay.
and the integration with the hardware, but we actually partner with a manufacturing company called Ligier. It's the largest supplier of lightweight electric vehicles in Europe, and they're based in France. And we're actively talking to companies here in the United States about partnering to find a manufacturing partner in the United States.
Wonderful. So they can be manufactured here as well.
Somewhere in the United States.
May
clear
or may
where.
not be in Colorado.
Right.
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 No, I got
Exactly.
that, but thanks for clarifying for the
Yes.
listening audience who doesn't crawl inside my brain. Nobody should. It's very dangerous in there. So I'm looking at your website on easymile.com, and it's a cute little vehicle. So it's of course, ladies and gentlemen, you can picture the shuttles that we're speaking of that you're already familiar with, and it's just like a little bit sleeker.
Yeah, there's no front or back, which is kind of interesting. So the vehicle can go forwards or backwards.
Okay.
Either way, there's no steering wheel.
Like a train, but without the tracks.
Exactly, but without any need for any added infrastructure. So it can operate on existing roadways today.
So it operates on existing roadways. How does it do that? Is it you get it all coordinated with GPS and it knows exactly where it's supposed to stay and it's not going to go off route and be wild?
So GPS is one example of the technology that's involved in it, but we use a combination of LiDAR, sensors, radar, IMU. It's a whole host of very redundant and safe technologies so that the vehicle has a 360-degree view around it. So at all times, the vehicle knows where it's at to an accuracy of 5 centimeters. It knows where it's going, and it's constantly looking around to look for obstacles, and it makes decisions about whether or not it needs to slow down or stop abruptly, depending on the obstacles around. So the vehicle actually operates very safely around other vehicles, pedestrians, cyclists, because of this technology.
So the vehicle is operating itself. It's not somebody someplace else operating it with a joystick or something.
Correct. That's right. It's got its own brains. It's been programmed for the route that it's operating on. Yeah.
But like a trail horse that's not going to wander off path. It's kind of nose to
Stay
tail.
on path. Yes, yeah. So it's not like the vehicle will decide all of a sudden I'm going to drive to
Interesting,
my
right.
friend's house or something like that.
Because it's programmable to that fine detail.
Yes.
Great.
Yes.
We're talking today with Lauren Issac. She's the Director of Business Initiatives for North America for Easy Mile, and this is an autonomous vehicle shuttle that can transport people wherever a shuttle is needed.
Yeah.
Right, Lauren?
Yeah.
So there's a lot of applications we could talk about. And we've talked a little bit about the jobs that might come here. So glad to have you here. What are you most excited about with this in a couple of seconds, because we'll come back for more.
Yeah, well, I have so much more to say about that, but I'm most excited that this is introducing the driverless technology in both a shared way, meaning it's more than one or two people, and it's electric.
That's
so no
very
greenhouse
cool.
gas emissions.
Okay, we'll talk more about that when we come back. Stay with us. Thanks so much for staying with us today on Connect and Collaborate. And we're wrapping up our week-long focus on Denver's build-up. We're looking at the different projects, the different partnerships, and so much growth that's happening in Denver and Colorado as a whole. Today I'm talking with Lauren Issac. She is the Director of Business Initiatives for North America for EasyMile. And EasyMile, if you look at the website, go to easymile.com. Very cool. These are autonomous vehicles that are, they're moving passengers more than, well, I guess an autonomous vehicle would, but it's not your individual personal vehicle.
Yeah.
It's going to be like, you can move a dozen people. These are nice little shuttles, be put into many kinds of applications.
Yeah, that's really what I'm most excited about, and it's truly why I joined EasyMile, because if you read the news about driverless vehicles, there's so much hype around every one of the automakers investing in this technology.
Right.
And putting these driverless cars on the road, which, quite frankly, it's still going to be many years before we see them available for sale. That's the first thing. And the second thing is that you introduce the potential for people to do a lot more, not just single occupancy vehicle travel, which means they're traveling by themselves, but also zero occupancy vehicle travel, which means you're sending your car out to run errands and do things for you without even being in the vehicle.
You mean I could order my groceries and they could just go put them in the car and the car would come back?
Yeah, and I talk to people about this all the time.
That's a great idea. Here we thought that was a great idea. Now you can just put it in the car.
Yeah, I mean, if you think about the potential of these vehicles running all your errands for you, picking up and dropping off your kids, it sounds amazing, but what's actually frightening is imagine if you were able to sit here and work on your job, but in the meantime, you were sending your car out to get the cheapest produce from one grocery store, the cheapest meat from the next grocery store, the cheapest toilet paper from the next grocery store, and then park in a remote parking lot where it's way, way cheaper, and wait for its next assignment. You're putting so many more miles on the road that we could have massive congestion. So there's actually really great incentive from a societal perspective to focus on these shared driverless vehicles. And I think we lose sight of that with all of the excitement that happens around, not just the cool technology, but also the potential that we as humans could leverage from that.
Well, and I think that's something, too, that you're still trying to wrap your head around having a driverless vehicle in the first place. You mentioned putting kids in a shuttle. I'm like, I want to put my kids in a car without me.
Yeah.
But I love how this driverless shuttle is such a great concept we can at least get used to the idea.
Yeah.
I can be in this vehicle with my family and okay, so this is what it's like.
Yeah, and it's an opportunity for maybe 2-car families to go down to 1 car or even no cars. It's an opportunity to introduce the driverless technology today, because what's exciting about this is these driverless shuttles are operating around the world, and it's still very early, but there's great potential for them all over the place.
Where are they now?
Yeah, so we've actually deployed over 100 projects around the world.
Okay.
So I mentioned we had a one-day demo here in Denver. We've had an over year-long operation in Singapore at a tourist destination called Gardens by the Bay. It's a horticultural tourist destination, and 2 shuttles are actually circulating around that to move tourists. So that's one example. We have 2 shuttles operating today in Arlington, Texas, transporting people from a sports stadium there to a parking lot. We have 2 shuttles in Bishop Branch, which is an employment center in San Ramon, California, which is in the Bay Area.
So it's one of these big, like a huge employer that probably has parking lots.
Yeah, massive, multiple parking lots. It's a gigantic private employment site.
Right, and so like one guy was driving this shuttle around, and now you can have autonomous vehicles that maybe have more of them.
Depending on
change
what
the schedule.
Yeah, absolutely. So there are examples around the world where they're operating, and we're finding that there's so much interest, even locally here in Denver and around the country and around the world. So we're as a company, we're seeing a ton of growth. So it's been really exciting for us.
So I like the idea that this is kind of an early adoption of the driverless vehicles you were mentioning. We can think of the concept. It's a ways down the road, but to have this to use and experience, I think takes it a long way too, right?
Yeah.
What about how do you regulate these? Is there, so most of us need a driver's license. We need the insurance for our vehicle. What kind of regulation obstacles do you come up with here?
We have significant regulation obstacles, actually, because these vehicles don't comply with the federal motor vehicle safety standards, which is something that all vehicles currently do comply with, because they have steering wheels and brakes and windshield wipers, and these are all standard requirements because those were written under the assumption that you'd have driving vehicles. So now we're doing everything with exemptions, and what's interesting is the House just passed a bill around driverless vehicle operations. The Senate has one that's been drafted and it's being circulated. What's exciting locally is in Colorado, actually, the state passed a bill, it was probably 3 months ago at this point, that's actually very permissive and very welcoming of the technology, which was another reason we wanted to locate here, is because we knew this was such an accepting state. But in general, it's a challenge. Government agencies are challenged because they do want to, and frankly should, regulate these vehicles because they're operating on our public roadways, but at the same time they don't want to stifle the advancement of the technology since it is so new.
Right, and I can imagine, and I think we've talked with some legislators here on the show, that it's tough because what do you then make permissible for a driverless vehicle that you don't know what's going to happen 15, 20 years from now? Have you given the right permissions? Have you put up the right restrictions?
Yeah,
it's
exactly.
touchy all the way through.
It's a challenge, yeah. And I very much respect the situation that the government is in, and we're, from the technology provider perspective, we're watching this evolve and trying to influence it as well. But the tricky part is, while the federal government is figuring this out, states are passing all different regulations. So California has one. Colorado has a different regulation, Florida has a different one, and some of them are not passing any of them, and some of them are saying you can work within our existing framework. So as a provider of these vehicles, we're having to look very closely state by state what we have to do differently.
Oh, that's really interesting. Yeah, because it's such a new concept, and I can see where different states would be, like, just like I said, if they're trying to figure out how much do you allow, what's the right way to open this avenue up, and not each state is going to agree, and then they're going to have to find a way to work together because they're all completely different right now.
Yeah, yeah. So it's an interesting challenge, and there are very significant lobbies that have been established from the automaker side, and then consumer protection groups. So there are a lot of very vocal groups in this discussion, and it's very much evolving by the day.
We're talking today with Lauren Issac, Director of Business Initiatives for North America for EasyMile, and this one's easy to remember. It's easymile.com. Go check that out if you're driving now. Don't do it now. If you were in a driverless vehicle, you could. But check that out. It's really interesting, and there's a great little video that goes along with showing how this operates. So many challenges. You are up against some challenges to get this going. Some people understanding what it is, how it would work, and I think that technology is what people are wondering about. How does it actually work? So you said it doesn't require infrastructure. So that's what's really neat about it, is you just set it down, program it, and it'll do its job.
Yeah, it just does its thing, and it's extremely reliable because you have technology that's been programmed to actually know where it is, where it's going, and to constantly read the world around it if there are any obstacles. So it's a very, very safe and reliable technology. In fact, we've operated these vehicles over 100,000 miles around the world.
Really?
And never had a single accident.
Wow.
Yeah. Yeah, and that's partially because of the technology we've incorporated into the vehicle, and it's also because of how and where we deploy the vehicles. So we won't put these vehicles on a highway,
right? Because
they're not ready for that yet. Yeah, and we know the technology. We know where it is safe. It can operate on colleges and university campuses. It can operate at business parks. It can operate around train stations. I mean, there are really great applications.
Well, I had an idea doing the break. That'd be great for, like, the state fair or something, to get people out from the remote parking lots into the area. Or
definitely. Yeah, that first and last mile connection, really anytime you're pulling people from, it could be a park and ride lot or any kind of parking lot to any kind of hub to hub movement where you may potentially not be able to transport every single person, but you could have mobility challenged people and you want to provide a mobility option
some access
for them.
That's a great idea.
Yeah.
So Lauren, you were saying that you had like a demo. Was this out at the Pepsi Center, you said?
Yeah.
So tell me, how do people react to this?
Yeah. So a typical reaction, which is so fun to watch, is people come with their cameras out, I should say phones out, but and they have to get their picture with the vehicle. They have to, video the experience of getting in and getting on. And so usually people start out very, very excited and ask lots of questions. And then they get on. And after about 30 seconds, maybe 60 seconds, you see this like moment of boredom where they're like, okay, it's operating, it's safe. There's really nothing absolutely remarkable to note. And then what's cool is when you get past that boredom, you realize that they start to apply how they can actually use this in their life.
It's exciting. Thanks so much, Lauren Issac, for coming on the show today.
My pleasure.